for having me here. I really do appreciate it. And I was thinking about this as I was getting ready for this last night. I was like, who would have thought we would be talking about stress after what is probably the most stressful week anybody's had in a long time. So, this is the perfect time to talk about this. And I want to acknowledge everybody who's here in their spare time to talk, to think about stress, because this is fantastic. I mean, if I were you, I'd probably just be sick of the whole concept of stress. So thanks for showing up and being here. I wanted to get, if I can, before we start, a quick show of hands of how many people here are high schoolers and how many people, why don't we start there? Do you guys know how to raise your hand? You go over into the participants and you could just hit, okay. Oh, or yeah, or throw it up in the chat. Perfect. High schoolers, anybody, middle school, oh good, okay, perfect, high school. Anybody, oh, a parent? Okay, perfect. All right. I just kind of wanted to know who I'm talking to, so I can adjust and make sure that that I'm I'm giving the information at the right level. I wanted to let you know I'm going to run a PowerPoint in a second. I don't do very well of looking at the chat while I'm trying to speak and run the PowerPoint. So Emma or Leah will be interrupting me. If there's any specific questions you have, do not hesitate to ask. But if it's not, if I don't look at it and I don't see it right away, it's because sometimes my screen gets set up so I can't see it at all. But someone just, I will make sure to answer your questions, and I have no time limit. I can stay until you guys want, have your questions answered at the end. Okay, fantastic. All right, so let me start sharing my screen, get my slideshow up here, get that up, start playing. Okay, fantastic. So I'm going to be talking, well, first off, my name is Elizabeth Hughes. I am a physician. I am a dermatologist by training, and I will tell you a little bit about why I got so interested in stress and the effects of stress a little bit later. But no, I'm not a psychiatrist, and I don't have a psychiatry or psychology background formally, although I have a huge amount of personal experience in dealing with stress and a huge amount of experience from sort of outside the medical realm of what stress is and ways to combat stress. And I'll tell you a little bit about why this is interesting to me during our talk. So stress really is the epidemic that nobody is talking about. And that's, if I do anything today, what I really want to do is make sure that people are talking about it and recognizing stress for what it is. So real briefly, I'm going to cover three things, three main topics. I'm going to talk about the epidemic proportion of stress. Like, let's talk about some statistics about stress. Because we're talking to, because people here are interested, are high schoolers, adolescents, parents of adolescents. I want to talk specifically about stress and the developing brain. I mean, the whole scope of stress and the physiologic effects is huge. So I decided I was just going to focus in on those topics for today. And then I want to talk about my backwards, outside of the box, upside down approach to stress for you. Now, the one thing I'm going to guarantee about this talk is you may well leave disappointed. And that's because I'm trying to take this enormous topic and squeeze it down into about 30 minutes with some time for questions. And that's impossible to do. And I recognize that. And so if you leave today just thinking, oh, I didn't, that seemed too superficial. That wasn't what, in depth enough, or I don't feel like I got a good enough handle on things. That's because the format, it's an impossibility to do it in this short period of time. but I will give you my contact information afterwards. I love questions. I love making sure people get information they want. So do not hesitate to reach out to me. And at the end, I'll have a slide about that. So if you do feel disappointed, I'm apologizing right up front. That doesn't mean what we're going to talk about isn't useful. It's just not going to be complete. Okay, so let's talk about the scope of stress and stress, how it affects our physical health. So 77% of people surveyed regularly experience physical symptoms which they attribute to stress. And I didn't leave psychological, but this, it's actually, here's an interesting thing. The number for psychological symptoms secondary to stress is only about 78%. So there's not a whole lot of difference. Stress is a physically felt with condition with health ramifications. And of course, if people are regularly experiencing physical symptoms, pain, headaches, fatigue, insomnia, things like that, they go to doctor's visits. And it has been estimated that somewhere between 75 and 90% of doctor's visits are for stress-related illness. So think about that for a moment. I'm a doctor, and let's say I have a full day of patients of 24 people, for instance. I see 12 people in the morning, 12 in the afternoon. Really, if you take 75% of that, I'm seeing, 20 people for a stress-related illness and 4 people for a non-stress related. So the consequences are huge and enormous. And when you think about healthcare expenditures, which I'm not going to go into, that's a bigger topic. But when you think about healthcare expenditures, taking care of stress and really, really eliminating stress is going to do more for our healthcare system and burdening our healthcare system, at least on the doctor's visit level, than almost anything else. I can't remember what it is. The sort of OSHA, the Occupational Health and Safety, has estimated that about over 200 million working days are lost per year. Or looked at another way, on average, 1 million people call out sick from work or miss work for a stress-related illness every day. 1 million people every single solitary day don't go to work because of a stress-related illness. Stress is also either the direct cause of or strongly associated with the 10 most common causes of death, including heart disease, which you can see, but there are things, well, I won't even go, I can go through the 10 most common causes of death, but they include things like strokes, heart disease, kidney disease, lung infections, respiratory illnesses, unintended accidents. And so this is interesting. Unintended accidents are the 3rd most common cause of death in the United States. And you'd say, well, accidents have nothing to do with stress. I mean, unintentional ones. These are not things where people were, angry and striking out because they're stressed. This is pure accident. But there is some amazing research by the military and by some industrial and occupational health, several different ways of looking at this. And I love the study that the military did, where what they looked at was people who had just had poor performance reviews or some other disciplinary type action in the military. And of course, everything's written down, so you have records if someone has been disciplined in their job. And then followed them afterwards to see if there was accidents caused or they were involved in an accident. And there was a significant correlation between poor job performance reviews and the stress of having some sort of military discipline and being involved in an accident, not causing the accident, but just having the accident happen. So stress is a huge portion of what makes us severely ill. It's not just little aches and pains that take us to the doctor, but it's involved in the origin and pathogenesis of heart disease and strokes and kidney disease and also cancer. So when you add all of these stress-related deaths up per year in the United States, it's more than 2 million. I mean, when you really look at it, more than 2 million people per year are dying of something that is caused by stress or significantly worsened by stress. Let me see what my next slide is. Oh, and so you might say, okay, so this year we got another cause of death. We've got COVID. We've got this virus that's around there. And I want to share a really, really interesting study that was done in London at the very beginning of the pandemic in March and April. At that point in the pandemic, what was happening and how the virus was causing so much illness was not clear yet. And a group of, I think it was two, it might have been 3 hospitals in London, decided to collect as much data as they could on newly admitted COVID patients. They were basically just saying, let's test everything and see what we can see. And one of the things that this group of researchers decided to test was cortisol levels. Now, cortisol, I'll go into the biochemistry a little bit in a moment, but cortisol is produced by the adrenal glands, and it is one of the main stress hormones. So when you are under stress, your cortisol goes high. Now, having some degree of cortisol response to inflammation and infection is important. It, for lack of a better way, it's sort of like gets your body, rallies the troops, gets your body in the mode of protecting itself, mobilizes certain biochemical resources like glucose and things like that to help work, feed cells that are fighting infection. So if you don't have cortisol, if you have a condition where you don't have adrenal glands, where you can't make appropriate amounts of cortisol, you can become very sick very, very quickly with infectious illness. So you need some of this cortisol. So what the researchers wondered, the researchers in London wondered, is maybe the people who are getting the sickest have low cortisol. Maybe they're not making enough. Well, it turns out exactly the opposite. The people with the highest level of cortisol, which is related to stress, the people with the highest level, wrong way, were actually strongly associated with more severe COVID symptoms, more hospitalization, longer hospitalizations, more likely to go into the ICU, more likely to need mechanical ventilation. All the markers were associated with this higher level of cortisol, which is a way of saying stress in this case. And again, I won't talk about this in length, but I really do think that this is a huge part of what's going on with COVID, is the fact that the cortisol, high cortisol levels do weaken the immune system at a certain point. You need some to make the immune system work, but too much weakens it, and then you run into problems. So even COVID, this novel infectious agent, is very clearly has an association with stress and the mortality from stress. Okay. So the WHO looked at all of this information and probably a little over 10 years ago now, declared that stress is the health epidemic of the 21st century. Not curing cancer, not eliminating malaria. And I would think if you took all the WHO and you put them together, they right now, as a terms of a century, they would not say the coronavirus. It really is, stress is the thing that is so directly related to health outcomes, and changing the stress the sort of culture of stress we have, which I'm going to talk about in a second, changing that would have a profound effect on everyone's health worldwide. Okay, so why don't I stop for just a second? Emma, are there any questions that are coming up in the chat right now?
I don't think so. I don't see any.
Okay, perfect. Thank you. All right, so let's talk about some chemistry, some biochemistry here for just a second. Stress is, well, I'll back this up a little bit. Whenever a person feels any emotion, stress, anger, fear, joy, sadness, happiness, excitement, any emotion is associated with a very specific cascade, a very specific set of hormones and neurotransmitters that are released into the body. And that process of release happens really, really quickly. So that in many ways, you've probably had this experience where you might have gotten news, and before maybe bad news, and before your brain can process how bad it is, your body's already having an emotional response. Or you could hear a loud noise or something something that sounds dangerous. You can, I live in earthquake world, you can feel the rumble of an earthquake, and before your brain can even say earthquake, your heart rate's already going boom, 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 and knows that something's going on. So it's the hormones and neurotransmitters, this little biochemical cocktail that runs through your nervous system and through your bloodstream, happens fast. It happens beyond the level of conscious control. And it's kind of like your body has this signaling mechanism. It knows when it's under threat or under stress, and your brain is sort of the last one in that chain of things that happens that knows about it. It happens quickly, but we've all had this experience where you feel stressed out or you feel worried, and then you realize why you're stressed or worried or concerned. So now I talked about cortisol. There are actually more than 1,000 individual biochemical changes that occur during the stress response. Cortisol and epinephrine are the two main substances that are released by the adrenal gland. And epinephrine's interesting because it's both a neurotransmitter and a hormone. So it works both through the bloodstream and through the nervous system. But those are the two big daddies, but there are more than 1,000 different biochemical changes that occur. And as I kind of alluded to, I think I said earlier, it's sort of a cascade. One thing pings and it signals two or three other, you could think it signals two or three other cellular groups that then set off their biochemical changes that triggers 10 others, and boom, 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 and in 90 seconds you've got a full body alert and response system, which is a good thing if what you're doing is actually you have to run out of a burning building because it's on fire, or you need to get yourself out of a car crash, or you need to get away, or you're being chased by a lion, or whatever it is. But it's not necessarily useful in the real world where we're not, I shouldn't say in the real world. It's not necessarily useful when what we're responding to as with the stress response is something like having to do a big assignment or homework or having a big test. It actually doesn't, this set of biochemical changes don't actually at a certain point help us anymore. And I'll talk about that in just a couple moments. So The other thing to know is that if you like you've gotten bad news and you're really angry or you're full of sorrow, or you're really really stressed about what you've just heard, there's a deadline, there's a test, there's something you didn't know about, you're missing something, whatever it is, your brain may then in a few seconds register, oh wait, no, I'm okay, but your body is still reacting as if this happened, with that stress response. And if it does not get re-triggered again, it takes about 90 minutes to go back to normal. So a single stress out moment can have, not can, does have ramifications which last for significantly longer, 90 minutes or so. So, and it's important to know that even though your brain may say, well, oh, I'm okay, I'm safe, this is not something worth getting stressed out about, your brain doesn't control that biochemical response. Really, your body has its own set of systems that are designed to keep you safe at a rate that is faster than we can think. The subconscious or the cellular systems of alertness operate quicker than conscious rational thought. And so that's an important thing to know. And I'll get into why that's so important in a second. Okay. Oh, and this was just showing that the biochemical changes just continue to rush through the entire body. Even if your brain's okay, you've got the rest of your body that is being affected by these hormones and neurotransmitters that have been released. So, let me then really hone in on stress and brain development during adolescence, because this is actually a really interesting and important topic that people don't recognize quite as much as they probably should. It's not, I'm going to state the obvious now. And just so you all know, I have one high schooler, a ninth grader, and another adolescent, a teenager who's just in starting college. So I'm right in the thick of this, and I know what it's like and what sort of stresses there are, especially around the time of getting into college. That's a mess. But it's important to recognize that the adolescent brain, even though a person may be full sized and grown, adolescent brain is not fully functional yet, and it doesn't mature until well into the 20s. And of course, with neuroplasticity, the brain continues to evolve and can continue to change, but there's a huge amount of growth that changes, but it goes way beyond when the physical growth or the physical end of that growth spurt starts. And I know you guys know this, but it's important to recognize what stress does to adolescent brains during this whole period of time, not just when you're 14, 15 years old, but when you're up into 18, 19, 20 through college years. So I'll back off for a second. There are two different types of changes that can occur with the stress response. The first is just purely blood flow, and that happens fast. Epinephrine controls your blood flow, controls clamping down of blood flow to certain parts of the body and opening up blood flow to other areas. And that change of blood flow is designed to help you run. If you dump a lot of blood, you dump a lot of oxygen into your muscles, and you will be able to run faster than if it's starved. But the body does this under the influence of epinephrine at the expense of other parts of the body, including the brain. And so when you measure blood flow through functional MRI scans, and you look at the blood flow that's going to the frontal lobe, which is our front of the brain, right behind the forehead, which is the part that makes us make good decisions. It's the part that has judgment and planning and helps us emotionally regulate ourselves. There is 1/4 less blood flow. And this is really important. Our brain takes up most of our oxygen consumption at rest. Our brains are incredibly metabolically active, and they need a lot of food, and the brain needs a lot of food and a lot of oxygen. So when you clamp down the blood flow to 75% of normal, in effect, the brain, particularly the frontal lobe, is starved for oxygen. It can manage for a little while, but it is not optimal. And because epinephrine is one of the chief uh, it's both a neurotransmitter and a hormone, as I said, and it's released very quickly in the stress response. This change happens really fast, really fast, within seconds. So, and that'll be important for what I talk about in a second about my approach to stress. But then let's talk a little bit more about the development of the brain, which takes place over a longer period of time. Unlike the vascular changes that are instant, the development is a slower process. So there are three specific areas that have been studied in mice and rats. Obviously, this isn't done in humans. You cannot take a human and specifically subject it to certain types of stress. That's not legal, and then you can't dissect the brain away. So the research here is based on rats and mice, but it is an important clues of what happens in the brain of a developing animal. And I will say here, as I talk about these changes, this is not situations of severe stress necessarily. These are not like, total deprivation and being kept in the dark and not being fed, that you might associate with severe stress for an animal. It does not have to be severe. There are different protocols in literature about what is severe and what is moderate stress. And so some of these animals that have had these changes have been subjected to just moderate stress for a couple hours a day during the period of time of adolescence. So it doesn't take a huge big T trauma idea. It can just take a little bit of wear and tear that we human beings are probably accepting as normal. So the hippocampus so stress in adolescent rodents inhibits the development of the hippocampus. The hippocampus is a portion of the brain that is responsible for memory and learning. This is a big deal for students. I mean, what is going to school? Memorizing and learning, right? So under a lot of stress, the exact thing that you want to do while you're at school to memorize and learn and retain information, if there's a lot of stress, that whole process is completely short-circuited because the hippocampus itself, the brain structure, is not the same. There's also the prefrontal cortex I talked about. That's the very front of the brain. Shows some atrophy or sort of like shrinking and weakening of the actual nerves, and there are fewer connections, fewer dendrites, which is the sort of accepting end of the neurons. There are fewer dendrites that are there to be connected with other neurons, so it's less complex. So you basically make a less complicated brain structure of your frontal cortex. And that frontal cortex, as I mentioned before, is your decision making, it's your planning, it's your judgment, it's moderating your social behavior, reading clues and taking in the big picture and coming up with an answer. And so as you go further and further along in school, and there's less of rote memorization and there's more complex thinking, And when you go out into the world and there's lots of complex thinking with not necessarily a right answer, you need your prefrontal cortex. But as I said earlier, there can be decreased blood flow to the frontal lobe, but you actually have a less robust, a less well-formed prefrontal cortex. And so it's a real hampering of future brain use. Now, at the same time, when there is constant stress in these rodents, the amygdala, which is the part of the body, the part of the brain that is involved in alertness and fear response, is increased. So when you're under constant stress, it's almost like you're going to look out. You're going to develop the parts of your brain that look out for more stress. And it has led some people to believe that constant stress alters the growing and developing brain to make it wired for anxiety in the future. I mean, the part of the brain that will make you anxious and worried actually gets bigger. So that's a really quick overview of what stress does to the developing brain. And this idea of being wired for stress is probably why a study done in 2014, 48% of people said, well, yes, I think I'm actually getting more stressed in the previous 5 years. And there's been a 400% increase in the use of antidepressants in that 20-year period from 1988 to 2008. And there are now diseases which were not unknown, but incredibly rare 100 years ago, which are now completely commonplace. And I'll just digress here and tell you why, and under the circumstances that I got so interested in this subject. It was, I want to say, wow, probably about 15 years ago. Somewhere in there, maybe 15 years ago, somewhere in that range. And I, as a doctor, I was doing what doctors do during lunch. I was checking my email, I was reading journals, and I was trying to eat, and I was trying to do it in 20 minutes. You know, multitasking, totally stressed out. And I'd been living like that, if we say, for years. Like just 4 years between med school and residency. And then I was working at a very busy teaching hospital at Stanford. And there was stress all the time. I never stopped working. And I should say that I was on call continuously for 8 years. And you might say, oh, it's just a dermatologist call, but I was getting called all the time anyway. Sleeping through the night wasn't necessarily happening. I did go on vacation, so it wasn't completely continuously. But this act of checking my email, trying to eat, trying to read, catch up on journals was pretty typical for me. And in my regular life, while I was functional as a doctor, I had a horrible anxiety disorder. I had panic attacks that were blinding and very, very frightening. And I was kind of a wreck from anxiety. So I'm sitting at my desk, I'm reading these journals, and in the American Journal, the Journal of the American Medical Association, which is one of the premier medical journals in the country, at the end of the journal, they very frequently do a look back, 100 years ago in medicine. And that journal that I was looking at that day while I was trying to triple multitask talked about Cushing's disease. Now, Harvey Cushing in the early 1900s identified a tumor of the pituitary gland, which caused an outpouring of high cortisol and epinephrine and caused a collection of symptoms in people, which included obesity, amenorrhea, or not able to have periods, infertility, high blood pressure, acne, stretch marks, etc., etc. And this, at the time, in the early 1900s, was an incredibly uncommon collection of conditions. But I was sitting there reading this and saying, wait, I saw 5 people with that this morning. I was seeing women with acne and stretch marks who were obese and had high blood pressure and were having difficulty or had difficulty with becoming pregnant. This condition, this collection of uh, symptoms and syndromes, which now we have all sorts of names like Syndrome X for and things like that, was really unknown 100 years ago. And Dr. Cushing identified a tumor that caused this problem, but it doesn't take a tumor to cause it. It just takes constant exposure to stress. And that moment, then I had to look at my own life and go like, whoa, I know where I'm going. And, I could just see what was going to happen to me if I didn't take care of my own stress response and then start using what I'm doing for my patients. So, which leads me to my approach to stress and stress response. So let me see. Let me go. Oop. All right. Most methods of stress management don't work. I'll say that again. Most methods of stress management that are commonly taught do not work as a long-term strategy. So things like mindfulness, I did it. When I devoted myself to this, I totally jumped onto the mindfulness train, and I was completely interested in mindfulness, and I was doing it all the time. And my mindfulness went like, I am miserable. I am miserable. I'm so stressed out. I'm worried. I'm going to be late. I was just very mindful of my misery, and it didn't really, really help. I would exercise. I tried, vigorous long-term exercise, running really, really long distances. And what I would do as I was running is I would think to myself, oh my goodness, I'm running too slowly. I'm running much slower than I did last time. But I still need to run this length of time, but I really don't want to. I was recreating the stress as I was trying to exercise and slow down. And what I realized is all of these stress management techniques are really like playing whack-a-mole with your stress symptoms. You bring up, the stress system comes up, you whack it down, but it's going to pop up somewhere else. Which brings me back to this question of this photo of the frog. There is an analogy, and I don't know if this is true, but there's an analogy or a story that if you put a frog in cool water and then start to gently raise the temperature, the frog will not notice that it's being boiled to death. And that's what we are really, really in. We are under so much stress in general. We are exposed to so many forms of stress that we are boiling and thinking that it is normal. We are having chronic stress-related illnesses, changes in brain structure, changes in long-term anxiety that we don't even know we don't even recognize it because we think it's normal. Just the same way the frog will start to think, well, that hot water is normal until it gets to a point where it can't get out. And what I found about the stress management techniques, where it was like taking this frog out of the water for a few seconds and letting it cool off, but then throwing it back in. And what I came to realize that we really need to do is we need to turn down the temperature of the water, turn the gas down, turn the oven off, or turn the stove off. So and really de-stress on a more systemic level. And one other thing I will say is you never, ever want to manage stress. Management is for things that you want to maximize, right? Money management, time management, resource management. If you're in a business, personnel management, or you might be running an organization, you want to manage the people, you might want to manage the agenda for a meeting, things that you want to that you want to make the most of, you manage. You don't want stress. So do not think about stress management, think about stress elimination or stress reduction. But stress management leads you to whack-a-mole, right? So some people will say, well, what about meditation? And I meditated for a long time. And what I found is that people, you would sort of say like, okay, I did my 20 minutes of meditation. You give yourself a green sticker for the day or whatever it is. And then what people didn't realize is, you spent 30 minutes meditating and another very frequently, and another 18 hours in total stress mode. So that 30 minutes, while it's good, it doesn't counteract what's going on the rest of the time. Your body, in order to grow neurons, in order to adequately distribute glucose, digest food properly, repair cells, have your immune system function, it needs long periods during which the stress response is not on. So this is my upside down, backwards way of thinking about stress elimination rather than stress response, which goes with thinking about your rodent brain. So rodents will spend, if they are under threat, they will do what? They'll hide, they'll barely move, they won't breathe, they will freeze up and clench up and wait until it looks safe. Before it gets out, it moves around, it goes and eats food, it does anything else that a happy little mouse will do. So basically what the rodent says is, when it looks safe, I will blank. When it looks safe, I will get out, I will move around, I will play, I will hang out with my friends, I'll go collect nuts, I'll do it. When it looks safe, I will blank. Now, remember what I said about your body registering stress before your brain necessarily does? Your body can also recognize the opposite of stress. It can recognize relaxation when you look out and see the world, around you as a place that looks and feels safe. So here's the crazy thing, to do this, you have to use your conscious brain to do exactly the opposite of what you think you need to do, so that your subconscious will get the message, oh, I'm safe, and it will turn your stress response off. So most people will think, well, if I'm really stressed out because I don't have enough time, I should manage my time better and I should work really hard on my time. Say no. You do not need to do that, because you are reinforcing the idea that time is a problem and you're not seeing the world as safe. You need to do something that is sort of the opposite of worrying about time, rather than trying to work more on time or work more on getting a good grade or work more on, whatever it is that has you stressed out. So the idea here is, if you're really, really stressed out and you say to yourself, I would rather be taking a nap. Oh, I wish I could go out and take a walk. When you're staring at your homework or staring at the computer screen, which we all are all the time now, and you just wish you could be doing something else, you probably need to. And that act of changing the pattern and doing something that you would do only if you were not stressed signals to your body to turn off the stress response. Now, one of the things is that this whole process is as unique as you are. There is not one size fits all. What de-stresses you doesn't de-stress me, and vice versa. So these specific tips and tricks and apps. I just had a great app, like do nothing for 30 seconds. Really? Like, okay, that doesn't do it for me. I mean, I recognize what they're trying to do, but there is no one size fits all. But the good thing is there is something that fits you, and you know exactly what it is that you need to do. It's just you probably haven't recognized it as important yet. So when I talk about stress elimination, stress reduction, I work with these sort of 10 categories of things that people can do to uh, to signal to their body and that they are not stressed, and actually reset their nervous system, turning off the stress response, turning off the sympathetic nervous system, and turning on the opposite system in your body, the parasympathetic, by doing these things. I'm not going to go into all of them right now. This is where you're going to be disappointed that I'm not complete. But I want to talk about a few of them. Animals, kids, humans, we play when we're not stressed. And we have a world where play is actually dismissed as childish and something that's not important. But play is incredibly important. It's, even if you're being active and it's physically challenging, it is incredibly nourishing for the body, and really turns off the stress response system, or the stress response. Things like getting messy, creating something, make a mess, do something that is quote unquote pointless for a little while. Incredibly important. When you are under stress, every action that you do has to be productive. Usually every minute of your day is timed out as something that you have to do because you've only got so much time, and then you end up in that time management thing. And the idea of sitting down and finger painting, seems ridiculous. But your body needs that. It needs to know, like, ooh, I can turn off that stress response for a little bit. For 30 minutes, I'm okay. Get some sleep. Not like this, though. It's not a good idea. But, if you need a nap, develop the ability to power nap. And don't feel guilty about it. Your body, your brain needs that rest. Your brain needs to turn off, and you need the blood flow to go back to normal. People talk about optimize your environment. Well, that's because everything we see around us tells us whether we're safe. And so this doesn't mean you have to reorganize your house. You don't have to remodel. You don't have to paint. Something like fresh flowers, lighting a candle, opening a window, closing a curtain, something about any little things like that, moving your furniture around. I do that not infrequently, actually. I was like, I want that over there. I want to put a new picture up. Actually, I do want to put a new picture up right back here. I do it all the time. Keeps the area fresh, keeps it novel, makes it more pleasant for me. Spend some time being bored off screen. That is hard right now, but doing something that is boring, a jigsaw puzzle, crossword puzzle, Rubik's Cube, something like that. Very, very soothing for the body. You would never do this, again, if you think about your rodent brain, you would never do this if the cat's around. You wouldn't sit down, let your guard down, and just play a game. And connect with friends. And connect with other people. This is one of the biggest things, and I have a whole bunch of information about the power of relationships, which I won't even go into because I think I'm already over time. I can't even see the time. But this is one of the most powerful things that you can do. And because what you really want is to have all parts of your brain working at their highest capacity. You want your intellectual left hemisphere and your creative right hemisphere, and you want your amygdala and your hippocampus and your prefrontal cortex all working optimally, all at the amazing genetic potential that you have. And so that's what your goal is ultimately. Your brain does function better off stress. So that was long. Thank you so very much for listening. I really, really do appreciate you being here. And as I said, that's my telephone number. It's my cell phone. You can reach me if you'd like. And that's my email. Don't hesitate to email. And so I am going to stop this.